Hello everyone, and welcome to your video on similar triangles. So first, let's define what we mean by the word similar. In math, similar means, and this is in layperson's language, it means that we are dealing with two figures that are the same shape, but they are different sizes. So, for instance, here is a nice equilateral triangle, and here is another equilateral triangle. These are the same shape, but they are different sizes. This one is bigger than this one. You could also have a right triangle and a little baby right triangle. Again, those are similar. So they have the same shape, but they have different sizes. Now, the sign for similarity, there we go, is this thing. It's like the squiggle that goes on top of a congruent sign, except there's just one of them and there's no equal sign underneath. Anyway, this actually has a name. It's called a tilde. And if you look on your keyboard, your typing keyboard, usually up here in this corner is where you will find the tilde button. So if you were ever looking to type one, now you'll be able to. Okay, the last thing that I'd like to do before we jump into the official definition is to note that, you know, in this chapter, we're talking mostly about similar triangles, but it doesn't have to be a triangle in order for similarity to come into play. For instance, I can have a big circle and a little circle. Those are the same shape, different sizes, they are similar. The same thing with a square. Here's a big square and here's a little square. Again, they are similar. You can even have it with rectangles. Similar. So, just so you are aware, we're going to be talking mostly about similar triangles, but the concept of similarity can be applied to a lot of different figures. All right, so let's jump in to the official definition of similarity. The official definition of similarity. And you should not be surprised to know that I'd like you to put this in your notes. So it says that triangle ABC is similar to triangle DEF if and only if the following things are true. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And that's an important part, we have AB over DE equals BC over EF equals CA over FD. Now I know that's a lot of letters, and yeah. So let's draw ourselves some pictures, shall we? Because that will make things much easier to understand. So we will draw a nice triangle. I'm not sure if this is an equilateral triangle, but it's a nice triangle. And if we label this triangle, we will say that this is A, B, and C, and this is D, E, and F. And here's what we know. We know that angle A has to be congruent to angle D. And so even though this is a smaller triangle, the amount of opening, the width of that opening is the same in both triangles. There's the same angle measurement. And the same is true here. We have angle B is congruent to angle E, and we have angle C is congruent to angle F. So that's one thing that we know. The second thing that we know, or that has to be true, is that these sides have to be proportional. So AB over DE, so AB divided by DE, has to be the same number as BC over EF. And that has to be the same number as CA over FD, right? So let's just put some numbers in here so that you can clearly understand what I'm talking about. Let's say that this is measured 10, 8, and 12. Okay, just go with me. Pretend like that's the case, right? If this over here is a 5, we know that these two lines, because we know that the triangles are similar, we know that these are in proportion to each other. And sure enough, you take this number and you cut it in half and you get this number over here, right? Well, in similar triangles, all of the sides are going to be in that same relationship. So we would take 8 and cut it in half to get 4 over here. And we would take 12 and cut it in half to get 6 over there. So whatever that relationship is between 10 and 5, that has to be true for the other two sides as well. All of these proportions have to be equal to each other. And we're going to be doing some examples of that. Here, let's do another example. Let's clear this out of here. And I'll put this over here. And we will do this. Let me see. I'll make a nice triangle here. And then I'll make another triangle here. And these are, they sort of look the same size. Let me do it again where it's clearly different sizes. Just because, you know, we're learning this stuff for the first time. Why make it harder than it needs to be? There we go. Clearly different sizes. All right, and let's have some numbers here. Let's say that this is 15. And let's say that this is 25. And let's say that this is 35. Okay? All right, so those are our angle measurement, or those are our side measurements. And we know that these angles are congruent to these angles over here. Okay? All right, so if we know, let's pretend like we know, if we know that this corresponding side of this triangle is a 3, you would say to yourself, using multiplication or division, how do I go from 15 to 3? Well, I divide by 5, right? So 15 divided by 5. That means that for the other sides of this triangle, I will take this number and divide by 5. So 25 divided by 5 is 5, and 35 divided by 5 is 7. So this triangle here is similar to this triangle because it is 1/5 this side, right? Writing it according to our definition, we would say that 15 divided by 3 equals 25 divided by 5, which equals 35 divided by 7. And if you multiply that out, I don't know, what is, 15 divided by 3 is 5, 25 divided by 5 is 5, and 35 divided by 7 is 5. See how those are all the same? That is because we know that this is a that these are similar triangles. So that ratio always has to be the same. All right. Now there are a few different ways to prove that two triangles are congruent. The first one is called the SAS Similarity Theorem. Please do not confuse this with our SAS postulate, which says that two triangles are congruent. Now we're talking about similarity, okay? And here's what it says. It says that two triangles are similar if and only if they have one set of congruent angles and the two flanking sides are proportional. So let's draw a picture. So let's say we have these two triangles. We got this one, and then we have a littler version of that right there, okay? And this is A, B, C, and this is D, E, F. So if we prove that B is congruent to E, and we prove that BA is proportional to ED, and BC is proportional to EF, then we know for sure that these two triangles are similar. Okay, so we would have to have one set of angles that are congruent, and then we would have to have two sets of proportional sides. So again, if this is a 10 and this is a 5, then this has to be like a 14 and a 7, right? It has to be in the same proportion. 10 divided by 5 is 2, 14 divided by 7 is 2. Okay? We could say, for our definition, we could say angle B is congruent to angle E, and AB divided by DE has to equal BC over EF. Okay? So that is your SAS similarity theorem. And again, that makes it so that we don't have to prove that each angle is congruent and each side is proportional, right? We can just prove part of that and know for sure that the triangles are similar. Okay, let's do another one. So here's another way that we can show that two triangles are similar, and that is the SSS similarity theorem. And that one says that two triangles are similar if and only if their respective sides are proportional. So if I have two triangles and I know this is A, this is B, this is C, this is D, this is E, and this is F, I will know that they are similar if A over D equals B over E, which equals C over F. And again, just to make sure that we are clearly on the same page, if I say that this is 3 and this is 6 and this is 7, then over here I could say that this is 9 because I'm going to have 3 be my magic number. So 3 times 3 makes 9, 6 times 3 makes 18, and 7 times 3 makes 21. So these would be in the same proportion. A divided by D is 3, B divided by E is 3, and C divided by F is 3. So you can see that the same proportion applies to all three sides, which means that our two triangles must be similar. Okay, and then there's one last way, and that is the AA similarity postulate. This is a postulate. And it says this. It says triangle ABC is similar to triangle DEF if and only if angle A is congruent to angle D and angle B is congruent to angle E. So if I had like this, A, B, C, D, E, F. If I could prove that A is congruent to D and B is congruent to E, then I know that these two triangles are similar to each other. And again, I'm very happy that I don't have to prove that every angle is congruent and that every side is proportional, because that would take a long time. This is a nice shortcut for us. All right, so that's it with triangle similarity. Remember, there are 3 ways to prove it. 3 ways to prove triangle similarity. We have the SAS, we have the SSS, and we have the AA. These are similarity theorems, not congruent theorems. All right, we're going to do a lot of work with this, so this will be a lot easier after we do some examples. You'll see, trust me.